All right, crew. So tomorrow, as you know, you are going to be taking a group quiz. And in order to be best prepared for that group quiz, this is going to be a really handy screencast for you. I'm going to give you some information that will move you in the right direction. So, first thing I want to make sure I pass on to you is this concept. Again, we talked about orbitals today in class. And we understand that these orbitals have different energy levels that they occupy. And if we were to take an atom, let's say we took an atom of iron, for example, and we wanted to show how the electrons, where the electrons were, and again, this is a probabilistic model that we're talking about, so we can't actually pinpoint exact location, but where we would expect to find them in terms of orbitals, we would use something called an orbital diagram or an orbital energy diagram to show you where those electrons were. So let's take a look at one of these things. Let's see. I'll go over here and put this thing in. I'm just going to pause it for just a moment. All right, so what I have here is something that I showed you guys actually at the tail end of class when your minds were probably already rotting. But this is an orbital energy diagram. And what you do here is you actually place a couple of electrons into each one of these boxes. Okay? Now I'm not going to tell you exactly how you do that because that's part of this group quiz that we're working on. But ultimately you should know that you're going to be using a diagram that looks a lot like this as you work through this group quiz. The other thing that's important to understand here is that this is a somewhat truncated version of the orbital energy diagram because it only goes up to, looks like the fourth energy level. It doesn't even complete the fourth energy level because it doesn't have a D or an F level there. So certainly it doesn't have a complete fourth energy level nor a fifth energy level at all. And you would have I should let you know that an atom that has more electrons is going to be able to have those electrons occupy higher energy levels. Okay? So you'll understand that. I don't expect you to fully understand that right now, but don't forget this diagram as we move forward. All right, so let's see. Let's cruise over to here. What else do I need to pass on to you, knuckle faces? Ah, yes, that's right. So sometimes we have things called orbital diagrams, which are not the same as orbital energy diagrams. They're a little bit simpler. Oh boy. Diagrams. There we go. And with orbital diagrams, they actually do in some sense show the energy because you increase in energy as you move from left to right. But it's a little simpler because it's not done on a set of axes. So we have a box here, and this would be the 1s box. And then we move further to the right for the 2s box. But don't forget that the second energy level also has another set of orbitals, 3 of them, which are the 2p orbitals. And then we move on to the third energy level, which has a 3s. It also has its own set of 3p orbitals, and then you would think that, all right, then we just go to the 3d level, right? So you go ahead here, and because it's at the third energy level, we can have a set of orbitals that will be able to contain, or there are going to be 5 orbitals. I don't actually want to reveal what it can contain exactly. And so you'd think, all right, well, that's the 3d. And in fact, you would be wrong, because this 3D here actually is at a higher energy level, oddly enough, than if we had a 4S that was hanging out here. Okay? And again, you can see how that would match up. Let me just move this a little bit right here. I'm going to select this 3D thing and scooch it closer. There we go. If you take a look here at our orbital energy diagram, notice that we have 1s down here. Whoa, I didn't mean that. Shoot, sorry. Did I just... Oh, you probably didn't even see it. I have 1s here, followed by 2s, the 2p's, the 3s, right? And then we can see 3p, And then what comes next energetically is the 4s before the 3d. So in fact, you can see that I haven't broken any sort of rules by having this 4s follow the 3p and be tucked in behind or before the 3d. All right, so this orbital diagram is something else that you're going to have to deal with, so be ready for that. The other thing we can do is create something called electron configurations. Hi, Rabbit. And with electron configurations, it's the most simple of all these things because you don't have little boxes and you don't have the axes. You just go something like this. So 1s, and if it's fully occupied, then you're going to have a superscript of 2. And then you have the 2s, and if it's fully occupied, that orbital, then it'll also have a superscript of 2. But then you also have the 2p, which if fully occupied would have a superscript of 6. Now, I'm not going to tell you right now what these numbers represent, because that's up to you guys to figure out tomorrow. That's mean, isn't it, that I don't tell you these things? Well, that's the whole point of group quizzes. It's to challenge you guys to figure things out that I know that you can figure out on your own, because you're tough and you're smart. And I even, I was going to say I believe in you, but I guess I can't say that. Okay, so let's see. Yes, one last thing. You should understand another concept here. In fact, let me go over to this side. The concept of an ion. Okay, so an ion. An ion is a charged atom. And an atom becomes charged when it either gains or loses an additional electron. So let's start off with the idea that we have something called carbon. Okay, you know that carbon is an element, and it's made up then of many atoms of carbon. And if we were just to take one atom of carbon, you would know that it has 6 protons. How do we know it has 6 protons? Because we look at the periodic table and see that there's a nice little comfy 6 associated where you would see the atomic number. And because it's a neutral atom of carbon, it also has 6 electrons. Oh, that's an E. Oh boy. Yeah, let me get rid of that. There. E. I'm writing E. There we go. E. And with that 6 electrons and 6 protons, we have a neutral carbon. But we don't always have neutrality. We don't always have the exact same number of electrons and protons, because if I gain an electron, suddenly I have a negative charge associated with that atom, and it's no longer called an atom or a neutral atom, it's called an ion. Or if I were to lose an electron, then it would be a +1 charge, and that would also be an ion. So you should understand that any particular atom is going to have a very common ion, its most common ion, where you would find in nature that atom would slip into that ion mode more often than in any other ion mode. And that might be a +2 charge, a +1 charge, +3 charge, etc. All right? So keep that in your fat little brains to understand the group quiz that you guys are going to be working on. All right, last thing I want to pass on to you guys. I think I'm going to move on to a new page. Just got too cluttered here. And this is a little bit of a fun little hint to help you figure out how the orbitals stack up in terms of their energy. So if you start at the bottom and write 1s, and then directly above that write 2s, and beside that write 2p, and then you continue to go all the way up, okay, just stacking them one on top of another. And don't forget, because we're at the 4th energy level, we have an additional one, which is 4f. And we're going to stop at that, but we're going to keep building up to the 5th energy level. Okay, notice that I don't have anything here. There's no need to do that. I'm not going to go into details of why that's the case, but just know that you don't have another letter associated with 5 there. We just keep stacking them on top of each other, and we go to 6s, 6p, 6d, 6f, and then finally the last level, 7s, 7p, 7d, oh that's a 7, oh boy, 7f, and that is the topmost energy level for all Well, actually, I was about to tell you something, but that's just totally confusing, so I won't. All right. So the way to sort of figure out the energy is you start in the bottom right-hand corner and you draw an arrow upwards. So that seems silly because you're probably telling me, of course I knew that was the lowest energy level. Well, just stick with me here. Because then you go to the 2s and you draw an arrow upward. And that would tell you that that's the next one. Okay, in terms of the energetics, it's the next higher. And then you go to 2p, but I want you to notice that I made my arrow go all the way up through 3s because 3s is the next one. And then I start here at my 3p and I cascade that guy all the way up to my 4s. So if you follow these arrows, you'll notice that if I keep doing this with my arrows, whee, just like this, those red arrows that are going up there, and you just start in the lower right-hand corner and move upwards, you can see how the order is going to work out here. Because I start off from 1s, right here, then I go to 2s, right here, then I go to 2p, then to 3s, it's these guys, and then I go, starting where I have the little asterisk here, I go to 3p, and then to 4s, okay, and then I start down here, and I go, oh crap, Chang, you suck. Oh, God. All right. Then I go 3D to 4P to 5S. Then go right to here. Then that goes to 4D to 5P. I think you get my point here. All right. So what that just did is it allowed me to go from the lowest energy, right? And if I go over here to the right, I get the highest energy level, okay, for electrons in those particular orbitals. All right, so that's just a nice little hint so that if you're stuck on how to fill things out later on, you'll know that you can always refer back to this cute little diagram. All right, you guys rot. I'll see you tomorrow in class. Bye.